Today we're going to continue talking about limits. We're going to talk about different properties of limits. Okay. This section will go together with section 2.4 for your next quiz. Okay. Next week, just so you kind of know what's going on next week, Monday we have Veterans Day Assembly. Wednesday we have Spanish field trip and Penta for the sophomores. And then Friday is NHS induction. Okay. I think there's only 3 of you that are in Spanish. Zach and Reagan. So we'll still have class that day like normal. Friday, you will not have class at all. You'll just go to study hall, like with the study hall. Okay, because I won't be here. We'll be gone. So that'll be Friday. Good? Okay. All right, let's get to it. Now, I don't know if you want to write all these down. I don't think you need to, but if you're somebody that likes to have it, that's fine. I just need you to understand that when you start combining functions, you still combine the limits the same way. So if you look at letter A, if I have the limit of functions that are being added, I can simply add the limits. Okay, so again, this is totally up to you if you want to write all this or not. If I have 2 functions that are being subtracted and I want to do the limit, I can just subtract the limits. Okay, same holds for multiplication, same holds for division. Please remember to make sure when you're dividing that the denominator is not 0, whatever it is that we're dividing by. Okay, it's kind of one of those things. Remember how I would ask you to find f times g of 4? You'd find f of 4, you'd find g of 4, and then you multiply them, right? Same idea here. If I ask you to find the limit of f plus g, you can find the limit of f, the limit of g, and then simply add them together. Okay, so that's what this top part is saying. If you do want to write them all, I'll post it for you, so you'll have it. Okay, or you can, obviously this recording, you can just pause the recording on the screen so you can see it. You have to assume that these limits exist. Okay, we know what it's like to have a limit that does not exist. Okay, if it doesn't exist, then none of this applies, kind of a thing. Okay, it has to exist in the first place. Now, again, I don't know if you want me to write this or not, but what do you think the sum rule is going to say? It's like this first one up here, right? A? Just add them, correct? What do you think the difference rule is going to say? Just subtract them. Product rule? I'm sorry, constant multiple rule. First of all, do you know what a constant multiple is? What does it mean to multiple? That's multiply, right? So if I have something, how do I want to write that? Like this. The limit as x approaches a. This is the same as just taking 3 times the limit. Constant multiple is when you multiply by something out front. It's kind of like a coefficient. Okay. But that's the constant multiple that you can simply, instead of doing the multiple in the limit, you can just pull it out front and multiply it at the end. Okay, so that's the constant multiple. We have the product rule and we have the quotient rule, and I'm sure you can assume that the product rule just tells me to multiply them and the quotient rule just tells me to divide them, making sure that when you're dividing, the denominator is not 0. Now, I really don't mean to gloss over this and make it seem irrelevant, because it is relevant. It's just very commonplace. It just makes sense. There's not a whole lot of explaining that has to happen. So I have 17 examples today. Some are harder than others. Some are not hard at all. Okay. We'll get through those examples and then that'll be it. Would you like me to have you write them and then we'll do them? Or would you like me to just take them one by one? Okay, I'll decide for you. We'll just take them one by one. Ready? First one. First thing I want to know is, what rule would we be talking about if I made you tell me what property this would be? Sum, difference, constant, multiple, product, or quotient. This would be constant multiple. Everybody sees a negative 1/2 out front, correct? Now my question to you is it an issue for me to plug in 16? No, it's not. So what's my limit here? 16 goes in here, right? And then you get -2. Fair enough? Okay. Number 2. What rule, if you were going to put a rule to this, would it be? What's happening here? Sum, difference, constant, multiple, product, or quotient. What do you see between all those terms, guys? It's difference, isn't it? Now, I'm going to show you what this would look like the long way. Don't write it. This is how you would apply that property. Does it make sense to do all that? It doesn't, does it? Because can I just plug in 4? Sure I can. Now, I'm sure somebody's thinking in their head, okay, I see the absolute value. Do I need to break that down into a piecewise, right? And the answer is no, because is this that I'm trying to plug in the critical number? It's not, is it? So there's no reason to plug it in. You guys remember how we talked about the critical number as the only interesting one in the whole thing? Well, if it's not the critical number, then don't bother doing all that. Fair enough? Okay, so plug in 4. We're getting serious now. Get off calculators. Oh, I'm gonna miss you guys when I'm done. Just you, though. That sounds so bad. That's so true, though. 14? 14's good? All right. Number 3. There are 2 properties, or 2 rules, that would be happening. We definitely have sums in each parentheses, and then we have products, right? So if you wanted to, you could actually split this one limit into 4 little limits. Does that make sense? You would have 2 from here and 2 from here, and then you'd multiply them. Okay, again, does that make any sense to do? No, not at all. Okay, am I allowed to plug this in? Yes? Please note this x is outside of that radical. Okay, so let's take it in pieces. What do you get in your first binomial if you plug in a radical 2? 7. What do you get in your second radical? 3. So your final limit would be 21? How are we doing? No issues yet, right? Now remember, this is all contingent on the fact that whatever we're plugging in is not interesting, right? Okay. How about that one? I would like you to realize here that there was no square root property, was there? That's not a thing, okay? We have sum, difference, constant multiple, quotient, and product. This would be a product because it's being squared, and you'd have a sum because they're being added inside that binomial. Does 64 pose us any problems? Nope. What's the cube root of 64? What's the square root of 64? So this would be 12 squared. which is 144. Okay, let's do one more easy one, and then we'll kind of bump it up a notch here. Haven't done a quotient property yet, so we'll put one here. Does -2 pose us any problems? Okay, so in your numerator, you should get what, -9? Denominator is -6. Mixed number, decimal, what do you guys prefer here? So, what do you guys prefer, mixed number, improper, decimal? Improper, so that would be what, 3/2? Okay. So, not that this is going to get much harder, you just have to make sure you're thinking about what I'm asking you for. Please notice it says exact form, which means, do I want you to type this in your calculator and get me a big old long decimal? No, I want the exact form of whatever this limit might be. Now, could you check it by using your calculator? Absolutely. Okay. Does 2, now that's a division bar in between there. Okay. Does 2 pose me any issues to plugging in here? Does it cause me a denominator error? No? Okay, so we can go ahead and plug it in. If I plug this in, I get e squared minus 2 over 2 pi. Everybody doing all right there? Can I simplify, reduce, cancel out, combine, anything here? No, right? I could try and factor the numerator, but is it going to help me with the denominator at all? Do I really need to cancel out the denominator in the first place? No, not at all. You're going to leave it just like this. This would be your exact form. So here we've got a product with a sum. Now, again, if we were going to write this out the long way, you would write that binomial twice. You would FOIL it out. When you FOILed it out, you would probably get a trinomial, and you'd do a 3-part limit. No reason to do that here. Okay. Does 1 pose us a problem to plug in? It does not. Basically, I get that. You can and you should FOIL this out. Okay. That's not too terribly difficult to do. Not difficult at all to do. Okay. What's e times e? 1e and 1e makes 2e. 1 times 1 is 1. And that would be my exact answer. All right. Let's see how much you remember about logs. Now, we haven't talked about logs in Calc, but you should have last year in pre-Calc. So we'll see what you remember here. Does e pose me a problem if I want to plug in this e? No, right? So that's what I'm looking at. Can I simplify any of this? That's the question. Can we do this, right? And the answer is no, because you have to have the ln of something, right? If you push your ln button on your calculator, it'll start a parentheses for you. You have to put something in there. Okay, so no, we cannot do that. But I want to know what the ln of e is. Now, when you put an ln, it's going to start a parentheses. When you put in an e, it's going to make you put a power in. So this is to the first power, isn't it? What'd you get? 1. Now, again, I don't know how in-depth you guys went in pre-calc. What is the base of the natural log? No, nothing? Okay, so, oh boy. Maybe we should have talked about logs. This is a regular log, correct? Okay, if I have, let's say, the log of 20, there's a base on this log. Okay, if there's nothing written there, the base is assumed to be 10. Okay. Then last year, you were asked to rewrite this in exponent notation. Does any of this ring a bell to you? Oh, goodness. Okay, so this is the base. This is the answer, excuse me. And then whatever equals is the exponent. Nothing? None of that rings a bell to you? Okay, well, don't worry about it. That's a whole unit that we could talk about. What I really want you to see here, or maybe remember, is that the assumed base of ln, if there's nothing there, is e. So really, this is ln base e of e. Does that make sense? Now, let's say you didn't have a calculator and you didn't know what it equals. Right? This is the base. This is the exponent. This is the answer. That's how you were rewriting them last year. So what does the question mark have to be in order for this to be true? 1, which is what you got in your calculator, wasn't it? You see how that kind of works? We're not going to spend time on that. Maybe I should have at the beginning of the year, but kind of too late now. So this is actually 1 over e for my final answer. There'll be a few times here and there where this comes up. Just remind me that I need to stop and go over it. Okay. Now, I don't know that we're going to do 9 and 10 because 9 and 10 could have been tested on our last test. Does -1 pose a problem? It does. So what are you going to do? Factor it. You're going to cancel it out. Then you're going to plug it in, right? We need to talk about that. How about number 10? Does 1 pose a problem? Yes. So what would you do? Factor it, cancel it out, plug it in. Does anybody need practice on factoring cubes? Because we can do that if we need. Yes? Okay. So if I factor a cube, it's a binomial times a trinomial. What's the cube root of x to the third? Okay. We keep the same symbol. What's the cube root of 1? Okay. So now for my trinomial, I'm going to square the first term, which is x squared. I'm going to multiply these together and do the opposite symbol. Is that okay? And then I square my last term, and it's always a plus. Everybody all right there? Oh, absolutely. As long as you remember that it has to go x to the third plus 0x squared plus 0x minus 1. Yep. Okay. Let's look at this one. I think you probably could figure it out at this point. We've done enough of these, I think, that what method do you think you should use to factor the denominator? By grouping. There's 4 terms down there, right? I guess I should ask you, is 3 a problem? I mean, there's no reason to factor if 3 is not a problem, right? This 3 right here. So this would be 27 minus 27 plus 3 minus 3. So it is a problem, isn't it? Okay. I forget what quiz it's on, but I throw one on there that is kind of like this. That's not a problem. So all you got to do is plug it in. Okay, make sure you check it first. Numerator will factor like this. Denominator, you said we're going to group. What can you take out of the first group? And then I have an x minus 3 left. Everybody okay? Grouping's good? You can't take anything out of the second group, so we use a 1. And then we have x minus 3 left. The repeated factor is x minus 3. The leftover factor is x squared plus 1. Please don't think you can factor that any further because it's a plus 1. You can't. Cancel it out. Plug in your 3. You get 5 over 10? A half? Anybody have any questions, concerns, comments here? How's your toolbox of ways to factor? Is it getting pretty large? I hope. We've got perfect squares, we got perfect cubes, we got regular factoring, we got GCF, we got creative factoring, we have grouping, we have long division. That's 7 ways that you have to factor right now. No, because it's like we take out a GCF. So do you see how they both have the x minus 3s? So we pull that out front as a GCF, which would be here. And then if you factor that part out, then what's left is your other factor. Is that okay? And again, I don't know that we need to do number 12 either. You'd factor by perfect squares in the numerator, right? It would cancel out the denominator by taking out a negative. Is everybody all right with this? Do we need to follow up on this one or no? Okay, I'm just trying to cover all my bases here. How about this one? We should be good on this one too, right? Just creative factoring by squares. Would you factor the numerator or the denominator? The numerator would factor into the square root of x minus 10 and square root of x plus 10. Okay. How about something like this? Is 1/27th is a problem, right? If I do the cube root of 1/27th, I get a third, and a third minus a third is 0 in my denominator. Now, I'm sure you're going to guess here that we're going to creatively factor this. Do you see how the numbers, the terms are kind of related? If I take the square root of this guy, don't I get this? Right? And if I take the square root of this guy, now remember what taking the square root of a power means. It means you're dividing it by 2, correct? If I divide this by 2, don't I get that? So that should be an indicator to you that we are going to factor by doing perfect squares. They're just not going to be your usual perfect squares. Should I factor the numerator or the denominator? Numerator. Okay. So what's the square root of y to the 2/3? What's the square root of 1/9? 1/3. Oops. Put in 1/27th. What is 1/27th to the 1/3? What's that? 1/27th to the 1/3 power. It's 1/3, right? What I put in there wrong? Kendall? Oh, yes, it is 1/3. Plus another third makes 2/3. How we doing? Good? How many I told you we had? 17? Yeah, we're almost there. Is a half a problem? Mm-hmm. So what are you going to do? Of what? 3? Do they cancel? They're opposites, so if I do cancel them, I got to put a negative out front. Now if you put in a half, what do you get? Mm-hmm. Yep, -6. All right. You tell me. Something you know how to do? What would you do? Yeah, are they allowed to be combined? Do they have to be split into two fractions? No, so wouldn't I just have an x squared minus 4 in the numerator? And then that just factor like usual, right? This one okay? Answer here is -4, if you're curious. Okay, and this will be the last one we do. I will strongly remind you guys that the only reason we're allowed to do these is because a limit exists. If it didn't exist, we've got major issues. Have to do something else. All right, is 0 a problem? Yeah. So what am I gonna do? Okay, so what would you make your two binomials here? Is e to the x times e to the x e to the 2x. If you're not, excuse me, if you're not convinced, when I'm multiplying and I have the same bases, what do I do with the powers? You add them. So what's x plus x? 2x. So this is okay, right? All right, and then I'd have a +1 and a -1. Do my middle terms cancel? Yeah. If I put a 0 in there, what do I get? 2. So I really hope that I've begun to broaden your horizons on factoring. Okay, you got to think of things outside the box. Calculus is not this long, straight, and narrow path. It is a big, wide hallway, and you got to figure out how to navigate that hallway. Okay, questions for me today? Okay, that would be your homework.